Hello again. In this session, I will introduce you with type of sensor in remote sensing. Sensors for remote sensing can be divided in two basic types, passive and active. Passive sensors, they need an external source of energy to create an image, for example, the sun in outdoor space or reflectors in indoor space. They detect the radiation emitted or reflected by the observed object. Active sensors need their own energy source to create an image of the objects they observed. An active sensor emits radiation towards object and measures the radiation reflected from the object. Further classification of sensors divide passive sensors into optical, hyperspectral and thermal, and active sensor into radars and lidars. Sensor can further be classified as sensors that create images, imaging one, and those that do not create image, for example, radiometer, thermometer, etc. Active remote sensing instruments operate with their own source of emission or light, like radar and lidar. Each active sensor in remote sensing directs its signal to the object and then checks the response. On this slide, you can see the division of the passive sensor into imaging in purple polygon and non-imaging sensor in red polygon. On the other hand, passive sensors depend on external energy, insolation mostly, bounced by the object. A division was also made between them into imaging in purple polygon and non-imaging sensors in red polygon. Microwave sensors can be both passive and active. Passives only detect microwave emission from object, distinguish natural energy and record it, while active ones radiate their own signal towards the object and measure the amount of reflected signal, like radar. The schematic view of the passive sensor looks like this. If the sensor uses reflected energy for measurement, they need an external energy source, marked with the orange polygon. It is reflected, marked with number 1, reaches a sensor that creates an image, marked with number 2, and then send image to the ground station, number 3. If the sensors use emitted energy, number 4, for measurement, the emitted energy reach a sensor that creates an image and then send it to the ground station. According to the construction, imaging sensors are divided into matrix or frame camera, push broom like scanner, and wishbone camera. A matrix camera creates a two-dimensional image of the scene at a single moment. A push broom scanner, also known as a long track or line scanner, is a device for obtaining images with spectroscopic sensor of 1 by 1 line of pixel. A wishbone, also known as an across-track scanner, and in a wishbone sensor, a mirror scans across the satellite's path, reflecting light into a single detector which collects data 1 pixel at a time. Hyperspectral imaging, on the left side of the slide, collect and processing information from the energy electromagnetic spectrum in a single file. This type of sensor creates images of the same area with different wavelength. These are mainly line scanner, push broom, that work in such a way that each line of the two-dimensional image you see on the slide show the same scene but with energy from a different part of the spectrum. According to the method of creating a digital number pixel value, sensors in digital camera are divided into charge-coupled device or complementary metal oxide semiconductor, CCD or CMOS. Digital color camera generally use a Bayer mask over the CCD sensor. Each square of 4 pixels has 1 filtered red, 1 blue and 2 green pixels. That's because the human eye is more sensitive to green than either red or blue wavelength. The results of this is the luminance information is collected at every pixel, but the color resolution is lower than the luminance resolution. On this slide, you can see examples of production of RGB bands with Bayer mask. Using blue, green and red filters above each pixel, the sensitivity percentage of each pixel stated earlier are provided. 50% for green and 25% each for the blue and the red part of the spectrum. On this slide, you can see the formulas for calculate the interpolation pixel at the scheme of creating a color image. Unlike the CCD sensor design, the CMOS sensor is designed in such a way that there are 3 separate detector layers webbed in silicon. These detectors are sensitive to blue on the surface, sensitive to green below, and detector sensitive to red below green. Thus, all 3 layers receive radiation of all wavelength, blue, green and red, to all pixels. It can be said that pixel value were obtained by direct measurement, that is, there are no pixels for which interpolated values had to be calculated. And on the last slide of this presentation, you can see the differences in the design of CCD and CMOS sensor and its way digital channels and color images are created. That would be all for this presentation. Thank you for your attention once more and see you in the new presentation. Bye.